Hello students, welcome back. We have another graph problem here, but this time we have two graphs. Red graph, that's graph of f of x, and blue graph, that's a graph of g of x. So we have to read two graphs this time. Okay, let's go. Find the average rate of change of f in 1 to 6, that is, find the quantity. Yeah, here we go, the average rate of change. The change of y-coordinate value over the change of x-coordinate value. The denominator is 6 minus 1, so I have 5, yeah, just 5. But the numerator, we have to find out what is f of 6 and what is f of 1. Here, f is red graph, so you have to read the red graph only. Disregard green graph, disregard the blue graph, excuse me, and just read the red graph. Just read the red graph at x equal to 1 and x equal to 6. Stop the playback and do it on your own. Tell me what you get. What is f of 1? X equals 1, and follow the graph vertically and hit the graph here, and that y-coordinate is 4. So that's 4. So that's 4. Oh, excuse me. I did f of 1, so that's 4. Now f of 6, 1, 2, 3, 4, 5, 6, right here. And move vertically and hit the red graph here, and what's that y-coordinate? 3. So that's how you calculate the average rate of change. What did I do here in my answer key? Well, that's precisely what it is. Find the net change. That is, find the quantity g of 8 minus g of 4. Our textbook uses the term net change. I hate it. Just g of 8 minus g of 4, come on. Just calculate these. G of 8, what is it? 1, 2, 3, 4, 5, 6, 7, 8, right here. And x equals to 8. And then move vertically and read the y-coordinate right here. What is it? G of 8 is 4. Now G of 4. 1, 2, 3, 4. And then move vertically. What's the y-coordinate? It's 2. So yeah, 4 minus 2, we get 2. Excuse me, I must have miscounted. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And then y-coordinate is 1, 2, 3, 4, 5. Sorry, g of 8 is 5. Because 5 minus 2, 3. Previously, I miscounted. This is right. Next, some algebra of functions. P of x is f of x times g of x, the product function. Q of x is f of x divided by g of x, quotient function. What is p of 2 minus q of 2? You gotta know some algebra of functions. By definition, p of 2 is product of two functions. So that is, let's see, let's do it this way. F of x times g of x That's my P. And Q is the quotient. Now we are interested in P of 2 minus Q of 2. So F of 2 times G of 2 minus F of 2 over G of 2. That's the quantity we have to calculate. Okay? You got to know some algebra of functions. P is F times G. So P of 2 is F of 2 times G of 2. Yes. Q is F over G. So Q of 2 is F of 2 over G over 2. So we get this quantity. How do you find this quantity? We can find out from the graph. How do you read the graph and get F of 2? And how do you get G of 2? Stop the playback and do it on your own. What is F of 2? X equal to 2, and follow the graph vertically, and function value is the y-coordinate right here. 1, 2, 3, 2, 3, 4, 5. So this thing is 5. So that's 5. And then this one here is 5. Now what is G of 2? X equal to 2 and move vertically until you hit the graph of G, and the function value is y-coordinate. What's the y-coordinate? 1, 2, 3. So this is 3, and that's 3. 5 times 3 minus 5/3. Make sense? This is what I did in my answer key. F of 2 times G of 2, F of 2 over G of 2, F of 2 is 5, G of 2 is 3, again reading the graph, 5/3, and then the rest of the computation is just calculator work. D. Find all values for which f of x is equal to 4. F of x, that's function value. Function value, y-coordinate is equal to 4. Y-coordinate, 1, 2, 3, 4. Y-coordinate is 4. Look at my mouse. Y-coordinate is 4. And then we have to look at the red graph. Here's one crossing when x equals 1. Here's a second crossing when x equals to 3. Let's see, do we have some picture? Okay, that's nice. Function value is 4. F of x is equal to 4. And then we have these two crossings, here and their x coordinates are 1 and 3 respectively. Okay, given x value, and then go to the graph and find out y coordinate. That's forward direction, and this is backward direction. Given y coordinate, move horizontally and hit the graph, and then find out the x coordinate by moving down vertically. Horizontal and then vertical. That's backward. Finally, find all x values for which g of x is greater than or equal to 3. G of x is equal to 3, then y is 3, so right here. Look at my mouse. And g of x is greater than 3, so we have to consider the part of the graph above this line. So this part and that part only. Like this. Y equals to 3, but this part and that part. Disregard the middle part because that's less than 3 in terms of function value. So greater than this part of the graph, but with the x coordinate values, so negative infinity to 2. Well, you could have considered just boundary negative 1 to 2, but either way you could have got full credit, so don't worry about that. And this part, 7 to positive infinity, this part of the graph, but read only the x coordinate. X coordinate going from 7 to positive infinity. Okay, we did a lot of graph reading problems. They're all important, even though they are hard. Still, they're so important that I always write multiple graph problems in exams. I mean, graph reading may be far more important than any kind of algebra we do in class once you step outside the classroom. Previously, I showed you some graphs of Dow Jones Industrial, S&P 500, and things like those. Yeah, I mean, those graphs and financials are one examples, but there are a bunch more. Many, many more graphs that you have to know. And what do you mean by the domain? What's the range? What does the x-coordinate mean? What does the y-coordinate mean? All those are extremely, extremely important. Make sure you understand all those.